Our next speaker is an EGSA member, Jason Knedlhans. Jason is a business development manager for generator equipment at UL. He is currently focused on service, customer relations development for generator products, including portable gensets, traditional generators, gas turbines, and controls for hydro and nuclear applications. He's also extensively involved in other power generation products such as photovoltaic and accessories, inverters, and battery systems. He has trained global engineering personnel and laboratory technicians on a numerous number of topics, including generators and photovoltaic safety and performance testing. Please extend a warm EGSA welcome to Jason.
Okay, thank you for the opportunity today to come and present to the EGSA organization, especially on the 50th anniversary. This is a great pleasure of mine and also for UL, so thank you for the opportunity. I'll be presenting on global standards development and how EGSA and everyone in the room here as distributors, component manufacturers, how we can all influence standards development to really streamline the process so that it's as easy as it can be for us, but we also maintain the right level of safety. So this morning I was at breakfast, and actually it was real cool. Had a sit down with a new member who, once he found out what we did, actually said, hey, you know what, certification makes my life easy, which I thought was amazing because maybe even just 2 years ago, if I were to talk to somebody in this room, they would say, certification makes my life horrible, right? So it was very good to see that the sentiment has changed. And so my presentation is how that standards can positively make things better and easier for us, set a bar for quality, reliability, and safety that can ensure the right people are in the market. And also I'll talk about how we can influence standards development and how we all own the process. So I start out with standards development, how standards are developed, how requirements are developed. Then I move into the domestic generator standards and look at their evolution over time, and then talk about global standards, and finally, how can we all influence global standards development. And there will be a Q&A at the end as well, so think of some questions while we go through. So requirements and standards are developed in 4 major ways. The first way is industry input. That's this upper left-hand picture there. This is a cool picture. This comes from the Columbia's World Fair in 1893. And that's when electricity was first presented to the major public. Edison and Tesla were at it at this point, and they had some input for us, and they said, you know, we're seeing issues with insulation materials. How can you help us to keep people safe and keep our installation safe? So we worked with the likes of Edison and Tesla and Westinghouse to develop standards based on their input and hazards that they saw at those times. Another way that standards and requirements are developed is through test research. So here we're showing a test research where we're burning a roof, which we do a lot. So that's one great thing about working at UL is we get to light things on fire, blow things up, shoot things. So that's always fun. So this is an example of how we did research to develop fire tests for roof equipment. Other things that we do, we actually have received grants from the Department of Homeland Security, and we have a full 2,200 square foot house that's constructed in one of our labs, and we simulate different fire scenarios. So starting new materials on fire, if you've ever worked with somebody from the fire department, they'll tell you that new materials, they burn much hotter, they burn much faster, they're much more dangerous to people inside of the home. So we do research like that to help us set requirements for furniture, for building materials, things like that, to really keep people safe, right? That's what we're looking to do. And that research helps us to develop the requirements. Experiments, this is another way that we develop requirements, and this is an interesting picture here. What you can't see is the lady's left hand is in a bucket of water with an electrode. So they're nice enough not to show that part. And you can see the little metal parts, those are actually electrodes as well. So this is the famous rice experiment. She has to manipulate rice into different containers while touching these different electrodes. What they found from this research is that women are much more susceptible to electrical current and can sense currents down to 500 microamps. And this may be even where she reacted or something of that nature. And it also helped us to set the 5 milliamp GFCI limits that we have in place nowadays. So you can see that these experiments like this help us to develop requirements and things that are still in place today. So we don't do many experiments like this anymore, as I'm sure you can imagine. And then the incident research. So this is more of a reactive type standards development. And what happens here is, this is actually an old tube TV. Back in the day, they had a lot of fires with tube TVs, especially in the UK, and found that some components were overheating in the system, and after their research in the field. So additional requirements were set for tube televisions back in the day, whether it was redundancy in the circuits or some type of overheating protection. And they also came up with a test where they smashed the front of them. I just think that was for people to have fun with. But yeah, so the four major ways that we develop requirements. So all of this comes together to develop a standard. And the major standard here for engine generators assemblies is UL 2200. That's shown on the right here. And a number of things come together to create standards. So the NEC, all UL standards must comply with the National Electric Code. This standard was developed in 1998. So the 1999 version of the NEC was used to develop the requirements, along with 1741 and 548. So these standards have those tried and true test methods already included in them from those experiments or research that we've done. And they come together with the NEC to form a standard that's requested by the industry or whatever drives the development of the standard. In this case, actually, UL 2200, there's a number of rumors that have gone around, but I checked with the real source, which was the person that developed the standard at UL, and they said that the HJs, and that's the local inspectors, actually drove the development of UL 2200. They said our inverter standards, which is mainly for PV use or DC applications, don't meet the need. Neither does this power inverters and converters for land vehicles. So they said we need something that addresses the prime mover, the generator, the fuel systems inside of these generators. We have to have something that covers all of that. So that's why the standard was developed. It was asked for by the local inspectors. So standards do not stay static. New things happen, new things come up. One thing that comes up quite a bit now is advanced functionality and controllers. So to accommodate those type of changes or forwards in the industry, the standards continue to be modified by what's called our standards technical panels. So you can see that UL 2200 was developed in 1998. At that point, we used UL 508, Industrial Control Equipment Standards for the controllers, which in 2012, the manufacturers in the industry came to us and said, this doesn't fit the needs of a generator controller. It's not controlling a process equipment in a factory. This is a controlling system for maybe even a hydro plant, nuclear plants, controlling the generators. So they said, this doesn't fit our needs. So UL said, we'll create UL Subject 6200, and that was published in 2012. And as you can see on the right side there, we're actually in the process of finalizing that into a UL standard. So it's great to be a part of this as this morphs, as the standards continue to advance. And the reason is that you all have an interest in this. UL has an interest of certification, providing the right certification to you all, but you all have to set the bar, right? That quality bar, that safety bar. what do you want to be as far as, or what do you want to be as an industry, right, is what you need to think about. Also, who do you want working in your space, right? What type of level of quality and reliability, like I said, do you want to set? So by all of you being included and taking part in these standards developments, that's how you drive what your industry is expecting and is required. So it's very important that you all stay involved in these certification decisions and the modifications of the standards. So we look at the standard itself, UL 2200. I'll go over some of kind of how the standards work, how they're set up, and this is basically how UL standards are set up. We have a construction side and we have a performance side. Construction side is things that are mentioned here. One cool thing is accessibility. We actually have a probe, again, research that we've done. It's a finger, it articulates, and you stick it in different holes to make sure that it doesn't get caught off by a fan, or you can't reach some electrical part. Those type of constructions. Fuel systems, bonding, all of that goes into the construction of the units. Performance, I've highlighted a few tests here that we see some non-compliances or we have to go back and work. One good one is the short circuit test. So the short circuit test, we short the output, which is always exciting, right? So that's where you see plasma balls, fireballs, sparks, all kinds of fun stuff there. So again, the good part of the job. Some other things there like the temperature test where you cannot exceed the temperature rating of the generator. So just verifying those things. Markings, you see that box actually goes from the construction all the way to the performance area. And you can imagine that some of the items are construction based, right? 3-phase is a construction aspect, whereas 480 volts is a verification through the performance of do you actually reach 480 volts? Can your unit actually operate at 40 degrees C ambient? Another thing that's often overlooked, instruction manuals. I think most of the major players are pretty familiar with this, but when we get new players to the US market, they're surprised to see that we have to have installation instructions identified, terminal torque, fuse sizes, things like that need to be identified in that installation manual. So sets that right bar of quality and make sure that the manufacturers consider those installation aspects, which many times are overlooked. And once you actually get into practically wiring something, you can see a lot different than theory on paper. Okay, so now we'll look at a few tests. Excuse me. This test here is the output verification test. You can see we have an oscilloscope. There's a load that can't be seen here. So we verify the output voltage. We also verify the output frequency and the output power. You might say, why does UL do that? Is that a safety concern? Well, you imagine if you can have a unit that does not have as high of an output rating, and you have some critical application, you may be overloading the generator and causing more harm to the unit than you need to, or overworking the unit. Whereas if you had an overrating, you could imagine that you could burn up cables, and if an installer is expecting to get a 300 kilowatt unit and they get a 400 kilowatt, again, you might have some issues there, right? Hopefully they know how to mitigate that with their overcurrent protection devices and everything, but just to verify that you're actually giving them what they say that you're giving them. Short circuit test, again, we run the oscilloscope here, we check the output voltage, the current, all that good stuff in that short circuit situation. So that's again a fun one. And you can see some cheesecloth on the right side of the unit with some black tape. And that goes over all of the openings so that, again, if flaming particles, all that fun stuff comes out of there. If it does not ignite that cotton, then everything's okay. If it does, then we have to go back and have them redesign or something. Okay, grounding impedance test. This is done in areas where the panels or something that sort of may become electrified. So you can see that we test from the ground connection all the way to the panel that may become live, and ensure that there's a good ground path there. 100 milliohms is the limit there. And verify that if somehow that does become electrified, that it's going to trip whatever overcurrent device and protect the user. There's also some things that we do at the temperature test here as well. So you can see that it's thermocoupled. Also, the right size cables are used, so we verify that the unit can operate with that cable size and doesn't overheat. Temperature test and blocked inlet. So blocked inlet, this is to simulate leaf buildup on the outside of the unit or any other type of debris building up on the outside of the unit. And we block the input of the unit, verify what happens. Again, another good test. Usually you see some coolant on the floor or spraying out all over, so that's fun for me, but not for the cleanup crew. And the temperature test. So the probes on the outside there on those pieces of wood, those are actually ambient probes to verify that the ambient temperature with this is within a certain range so that the test is in compliance with the requirements. And you'll notice some cheesecloth up there too on that back generator there that must be doing an abnormal test. Another good test, the rain test. So the tests I'm showing you here are ones that we normally have some non-compliance or we see people have to go back and do some type of redesign. So the rain test, we run at 5 psi. It's amazing how this drops come out of there. Some genius designed this spray head, and it's literally like it's raining on you. I don't know, it's just amazing. 5 psi creates exactly, simulates perfectly a raindrop. And the 3 spray heads spray different areas, different air intakes, and you have to verify that water doesn't get on or above live parts. Here we often see some need to redesign the louvers or some type of intake to make sure that it meets the requirements. Okay, I think that's all we have on the tests. So, in addition to standards development, the requirements, all of this good stuff, where does it come from? Why do we need it, right? Is it just we have it out there because it sounds good and it makes us all feel happy? Not necessarily. They're driven by 3 main drivers here. One being the HJs, so this is the local inspectors. They have their own codes, right? They may even operate off of the 2011 National Electric Code. I've seen some people operating even further back than that, 2007 National Electric Code. So each jurisdiction has their own requirements. So this is what we call HJs, and they drive the need for certification. In addition to that, OSHA drives certification needs, right? They have a whole list of standards that apply to different pieces of equipment that must be certified when used on a job site. So depending on their inspection level, you may get caught in this or you may have not, but the UL standards are listed in those OSHA documents. And probably the most dynamic and probably the most influential as far as forwarding requirements is project requirements. And I think of, I was in the Middle East recently working with Saudi Arabia and Saudi Aramco. And Saudi Aramco requires UL certification on their products, or if not UL certification, some level of IEC certification. So it's important to understand globally the players and the different certifications they're going to be looking for as you look to expand globally. Not only that, it may be even just a consumer would like to have a certification on their product within a specific region, but usually we see a lot of projects requiring this. And in gas and oil applications, that's big. They'd like to have that little bit higher quality than maybe just no certification or some of the self-declared certifications. So I think of it as a spectrum. We start out on the left-hand side, this residential commercial area. Those are governed by the NEC, pretty straightforward, have to have certification, UL 2200 or the like standard. And then when you move into the industrial space, it depends, right? It depends on how critical the need of the generator is, where it's being used. A lot of times you see project requirements in this area. Maybe a particular user requires UL listed products. Exploration and infrastructure. This one could actually kind of move to the left a little bit now. After the large oil spill in the Gulf, the offshore folks have requested that we not only have ordinary location certifications, but we also have hazardous location certifications. And what those are is that's ensuring that that generator with its hot generator, the engine, hot exhaust, all that good stuff, does not ignite the environment. You can imagine on an offshore oil rig, there's a lot of flying particles, small pieces of oil in the air that ignites very easily. So now they're asking for a higher level of certification so that the same type of event doesn't happen that happened in the Gulf recently. So it's very dynamic, right? It's not just a static certification world out there. So again, that's why it's important for us all to be involved in the standards development and understanding where it's going so that we can drive the certifications and maybe it's not too restrictive to getting us to the market. And then utility. I've done some testing out in some waste fields, processing some raw gas. So we do see it here. Mainly that's some field inspections where they want to ensure that the connection to the grid is suitable and that trips off at the right points or at a low voltage situation, it actually allows the unit to continue and support the grid. So depending on the local utility's needs, there may be some certification requirements there. So we have the spectrum of where it's applied, right? And I mentioned Saudi Aramco. I also mentioned offshore applications. So it's also very dynamic throughout the world. There's many different standards that govern engine generators and their components globally. You can see in Canada, they have a couple standards and they work at the component level at this point. There's also some additional standards for fuel systems that are applied there. And then in the UL, we have a number of standards going from the full system, UL 2200, the controllers, UL 6200, and some other standards such as 1004-4, which is for the generator components. And then in the Middle East, some of this, the EU, they traditionally use the IEC standards. And the main standard there is 60034. And you can see the rest of them. I won't go through all of that. One interesting part is at the top there, the machinery directive. In the EU, it's all self-declaration, so you get the CE mark. And you use these different directives. This EMC and the ATEX directive have to be done by a third party. So that would be somebody like UL, Intertech, TV, CSA, somebody like that. And the machinery directive you can do yourself. So a little bit different than certifications required or certificates required in the Middle East. In Australia, you have to bring not only your certification, but a bunch of documentation indicating that your fuel system is in line with what they need. And then you can see over in Asia, India, and ASEAN, really there's not too many requirements that are applied. So again, very dynamic. One takeaway from this slide is that it's important to understand where you want to sell your units or your products or your components, and that's going to help you decide what standards you want to pursue. So if you're looking to expand into Latin America, Africa, the Middle East, and EU, good idea to go for those EN/IEC standards. If you're going for North America, UL with a combination of the CSA standards probably gets you what you need. So again, the takeaway here is just understand where you're going globally and what certifications you need, and we can definitely help you with that, along with the other certification organizations that are part of EGSA. So globally, standards are developed. As we saw, we have the IEC standards, we have ISO standards, there's EN standards, ATEX, they're just all over the place, right? I don't even know how I keep track of it half the time. So in the US, we have a standard organization, ANSI. And they actually drive the majority of standards requirements and development within the US. And they have a process that they require that all of these people within that US block there are required to follow. And it breeds balance, fairness, and a few other things that I'll present on the next slide. But if you ever notice, you look at UL standards and it'll be an ANSI UL standard. That means that it's been approved and the method of developing it has ensured that people, again, like in this room, have had their say in development of the standards and the requirements so that it doesn't either hinder the marketplace or make it too easy to be working in the marketplace where you don't have that right level of safety or reliability. So you can see a number of organizations there. The NFPA, of course, writes the National Electric Code. The US government, yes, they have some say. So the Consumer Product and Safety Commission is actually presented UL with a letter stating that they're interested in figuring out how we can work with portable generators to reduce the risk of death by people when they operate their units indoors or in their garage. So a lot of different input goes into the standards, and we have to definitely consider that. And you know, sometimes it's interesting input that may delay standards development, but hopefully we can get through some of those things and help us get to the right spot quickly. EPA, you're all aware of, you know, the whole emissions testing that we've all gone through over the last few years. And then some international standards development organizations. ISO develops standards globally, and actually they get one input through ANSI, which is the US standards development team, and they only have one voting right for the ISO standards. So it's very dynamic again as well there and how the different interested parties come together. Standards development. So influencing and advancing industry, like I said at the beginning. This is how we influence an advancing industry. Like I said, it's very important for us all to be a part of the standards development. Even if it's you have input with some key people and you can't necessarily be on one of the panels, there's a lot of people that I know in here that do some really great work with UL and international organizations to make sure that your interests are heard. So please find out who those people are. And I can help you identify some of those people, but engage them and see how you can become a part of this, because it's really how we can make sure that we influence the standards development properly. So this is the process of how a standard is developed. You start out with some industry or market need, and we work through either drafting some type of document that is like a UL 6200, right? It's not a full standard, but we've drafted some requirements based on input from the industry. Then we create this working group, which is formed of people like you, like I've been mentioning. And then we go into research and what we have from field experience, and that helps us to develop the standards. With that working group. Then the working group comes to a consensus or some type of voting, which was really brought out to light by Herb in one of his recent publications in the Powerline magazine. He mentioned that there was a vote, and there was 20 available people to vote. 10 voted yes, and 1 voted no, and 9 didn't vote. Right? So that shows you that that could have definitely been swayed a different way if all the participants were to have voted. Okay, so very important. Publication of the standard, and then you can see there's kind of a feedback loop there where we take the input and modify the standards as technologies change and the such. So again, this is some key areas where both EGSA and yourselves can help to forward those requirements. Is industry feedback, I think, is one big thing that if you're not on a panel, you can provide data. You can provide input as to, you know, we haven't seen an issue with an overspeed or a backfire situation in 30 years. Let's modify the standards so that we don't have to run a backfire test anymore, right? We have such advanced engine controls nowadays that's, I mean, it's nearly impossible, right? So think about those things. How can we provide that input? at both an individual level and at an EGSA level. And I know I've been harping this whole time, but it's standards set the bar. I'll leave you with this last image. Really, again, we set the bar of who we want working in our industry and providing product within specific regions based on the standard requirements that we set out. So I'm sure that we've all had some concerns with that recently, but how do we ensure that we have the right level of quality, reliability, and safety in the marketplace and really drives quality products? Okay, so that's my presentation for today. Thank you. And now we'll go into a Q&A.
So I'm not really that familiar with all the standard details and so on. So when I ask this question, I hope it's not, if I read it, I get the answer. But as far as things like weathering and wear and tear and things like that, is there any type of measurements or testing that you do that you might have to worry about things, 20 years down the road, 30 years down the road, that you don't know just by the UL testing that you're doing or things that you're looking at now?
Yeah, that's a very good question. We get that question in many of the distributed generation systems. No, UL standards do not look at a certain duration of reliability or functionality. They're to test it's a type test, and what that proves is that the design meets a certain level of criteria. Those criteria may correlate to some duration, but it's just a consequence of how it's all come out. But it's not necessarily meant to say your generator is good for 25 years.
How does one protect oneself against a failure before someone takes the initiative and says my equipment doesn't work, or reliability or safety? How does one in the marketplace know how to approach it?
So the question is, how does somebody in the marketplace approach the situation where the unit may not operate in the future? And how do you mitigate that? I don't really know. That's something that's kind of like a reliability, durability test that I think each manufacturer has to take on. But I can tell you that certification of components is a great place to start. A lot of different components, valves, tanks, enclosures, generators, all of those have certifications. So if you can find those type of products, you have a good sense that those are going to be quality products that are going to last for whatever duration that may be. But yeah, the standards don't directly address that. Yes, sir.
Jason, my name is Herb Doherty, and I serve on some of the committees representing EGSA along with Herb Whitall. I'm on the UL STP 1008.
Oh, great.
And some of the NFPA committees. I was interested in the map you showed of the global standards and UL and IEC, and I know there's a lot of work with harmonizing CSA and UL and standards in Mexico. Is there any work being done to do more to harmonize UL with IEC and ISO and sort of getting them all on the same page?
Yeah, that's great. That's actually a really good question, and that's my goal as a business development manager is to make that happen. Yes, UL is a part of TC 70 now, which is the technical committee for internal rotating machinery. So we'll be working with them, and ISO helps to develop not only ISO standards, but IEC and EN standards globally. So hopefully through that North American representation, we'll be able to better harmonize the standards. Right now it's a little off. IEC has a way of looking at requirements which is a much more performance-based versus UL is much more construction type based with somewhat of a performance in there. So melding those takes a while. I know there's been some standards in some other areas that it's been 5 years that we've been trying to harmonize. So it doesn't happen quickly, but yeah, definitely the goal. You got it.
Thank you.
You're welcome. Thank you.
Jason, can you talk a little bit about what the mark means on the product and how the process that a manufacturer, whether it's a genset or a toaster, goes through to obtain the privilege of putting that mark on the product?
Okay, sure. Yeah, good question. Thanks, Steve.
Like I mentioned on the one slide there's kind of two aspects, right? We have the performance and the construction. So what a manufacturer has to do is submit the construction of their unit. That's drawings. Usually we go out and take a look at the unit. Again, we test it with the probe. We do some measurements and such to verify the construction. Look at all the components, make sure they have the right level of certification. And then we go back and create a report that documents all of those critical components. We run our tests, so the UL 2200 test program. And if everything goes well, then we are able to provide the mark. So the mark doesn't just mean that you've complied with those tests, but it also means that you're under quarterly surveillance on those products. So somebody would go into the manufacturing facility and verify that those continue to be made per the UL file. So again, it's that certain level of quality that's kind of maintained there, or consistent construction. So two parts.
My name is Jim Wright. I'm a retiree from Marathon Electric.
Oh, great.
My question is, when I first got in the industry in the late 60s and early 70s, the generator standard was CSA. And it seemed to work. And then all of a sudden, here comes 2000, and it seemed like UL was going to out-Catholic the Pope. And they were going to drop things down, make it harder. And, you know, I have very little voice in that sort of thing, but I wonder, we were already paying a whole bunch of money to be CSA certified. Mm-hmm. Then we get UL 2000, and whoops, you're selling this paper again, so we got to go out and pay more money to get your paper, and it worries me.
Yeah.
Why didn't you just go ahead and say a standard that's been in business for 20-odd years seems to work? Why change it?
Yeah.
That was my question.
Yeah, I like it, actually. Thank you for challenging us. I appreciate that, because you know what? That's how we've gotten better. So, yes, UL has maybe not been the most customer-friendly company, and standards development hasn't been the most customer manufacturer-friendly type situation over the past 100 years, right? But if this helps, what we're looking to do now is we are looking to harmonize all of those requirements from the generator side. We're actually also looking at creating a UL 2200, ULC 2200, which you get one certification and you're covered for pretty much all of North America, from Mexico to Canada. So that's what we're working on now. Why reinvent the wheel? Because you're exactly right. Why? And what does it do? It just slows you down. It slows your process down. And increase costs, right? So exactly. How do we, make that so it's as efficient as possible? So we're definitely working on it. So thank you for that, though. Okay. Yes.
Great topic. Everybody pretty much has opportunity or has needs to make changes after they leave the factory. What code is it that deals with how much change can you make before you start violating the UL rating? Okay. I've seen some pretty radical modifications, which to me isn't playing by the rules. But then you also have the other end of the scope where little changes are a necessity.
Yeah. So that's actually an issue of the local inspector, right? So each local inspector gets to determine how strict or not strict they are with applying the requirements. But the rule of thumb is that if you change anything that's in the documented UL file, like I mentioned from Steve's question, if you modify anything outside of, or that's included in that, then you have to recertify your product, whether that's in the field or wherever it may be. So that's the trigger. Yes, sometimes people do get away with those, larger changes, but again, that's where we all come in to say, hey, if you make this type of change, this is what you have to do. So that's the rule of thumb. We do have people that go out and look at the units in the field and inspect them for construction concerns and performance, so it goes on both sides. But yeah, it's not universally applied due to the local inspector variability. Okay, good. Yes, sir.
We got Steve Oxley from Kohler here.
Oh, okay.
Jason, can you go through the process or what it takes to be an STP member and how that process works and how EGSA members can participate in that procedure?
Oh, good. Yeah, thank you. I probably didn't go over that too much. So the STP, Standards Technical Panel, is formed by UL under the ANSI approval, and we can't have more than 33% representation from one industry group. So the industry groups are manufacturers, distributors, component manufacturers, government officials, local inspectors, and education and consultants. So we cannot have more than 33% from each of those groups. If you're interested in being a part of the STP and we can accommodate you, considering those balance requirements, feel free to talk to me. And sometimes what I say is, you know what, find an ally, find a friend. If you're a manufacturer and we've hit the limit of manufacturers, go out and find a distributor that can join you, because then you've changed the balance, right? So think about that. Think about how you can bring people that are going to have some of your same interests, also maybe somebody that might have a little different interests that can help us get us there. So even though we've met that balance in many of the standards technical panels, it's worth it to see if you can bring somebody to help you. So good question. Thank you. Yes, sir.
Oh, Steve Evans. You mentioned a couple times the AHJs.
Yeah.
Is there any effort made to train the AHJs in different areas for degree of consistency? We've seen very inefficient, or I shouldn't say, inconsistent enforcement and compliance with the code with the different AHJs.
Yeah, really good question. UL and I think other certification bodies have a regulatory service group. And what they do is their sole job is to educate AHJs. I sent out a mailer last year about some different requirements, and that was sent to over 2,500 AHJs. So it comes down to whether they're involved, they're engaged, they read these notifications, they come to the educational groups or whatnot. So yeah, we do reach out to them, we actively engage them and show them the different updates. It's a matter of whether they actively engage and learn about it. That's more.
Certified or approved of any kind to be an AHJ?
No, you do not. No. So it's just by the local county or jurisdiction that approves you. Yeah. Many of them are, come from some trade, right? They're an electrician or a plumber or something like that. So, but yeah, good question. And I think that's a way that we could get more consistency. But you see that globally. Even you go to Europe and each inspector in each town will give you something different. So, yes, sir.
Hey, Jason, my name is Steve. I'm with Chillicothe Metal Company. I'm just thinking back to your one slide on due process and transparency. And I've been involved with EGSA since 1991, and we are the pulse of the on-site power industry. Yeah. And my question is the cancellation with no notice of QRNZ and the implementation of FTPP with absolutely not one packager in this organization having any knowledge of that whatsoever. What was the driver behind that, and why was there such a lack of transparency and due process? And what is the quantifiable value of FTPP today? Because honestly, I don't understand it.
Okay. Well, I'll try to answer it quickly, and we can talk about it maybe offline as well. And not that I don't want to dismiss your question. Things were developed a little bit differently back in the day. I came in maybe 2 to 3 years ago to manage this industry for reasons exactly like that. Why were we implementing different certifications without checking with the industry and verifying that it was really going to meet the needs of everyone in the industry, right? That was an issue. So we are looking to make changes there, and we have already. FTPP, it was originally requested by enclosure manufacturers and AHJs out in the field. They didn't have some type of certification on the enclosure once it was put on an open unit. So how do we prove that the combination of those two are acceptable? Well, in my mind, I think we missed the mark a bit, right? Because there still needs to be some testing or evaluation done on those enclosures, whether it's some airflow analysis, whether it's whatever it is, something needs to be done, because just a construction review of that doesn't really meet the intents even of UL 2200. So yeah, some modifications need to be made, and you'll see that we're actively managing the industry now a little bit better than we have, so we don't have this type of issue in the future.
Okay, and how will you communicate that ongoing improvement? How will you get that message to EGSA?
So there's some people here that are taking on that task, and they've actually been put on a working group, and it's my take that they're responsible for bringing that to the Codes and Standards Committee, and we discuss it there. So that's how we usually bring it back, is through the committee. But that's actually a good point. Maybe there's some way that we could get it out on the EGSA website or something when we have major changes like that. That's actually something really cool to think about. Let me think about that with some of the guys.
One other question, I think Dennis Roundtree.
Yeah, I think we're at the end here.
So, you know, in regards to, say, 2200, the development of UL 2200, you said it took place in 1998.
Yep.
Again, you know, I understand why an AHJ or a group of AHJs, is this working?
No, it's not.
It's fun to watch.
Kim set you up there.
Not working? Okay, I'll try to speak.
You look good with it.
I can understand if I'm an AHJ why I want standards. I want all standards. I want labels on everything. And especially if I'm an insurance organization.
Yeah.
I want labels on everything. But the reality is, I've seen, I'm not a generator set manufacturer, but I've seen the cost that UL 2200 has brought to the industry. And so I go back, my mind wants to go back and say, I'd like to understand better the justification process for UL 2200. Because at some point in time, the products have to be increased in price to offset those costs. And it also creates, indirectly I'm sure, but it can create barriers to entry. If you're a great big huge company, you've got budgets for these types of things, and you can use them to your marketing strength. Whereas a smaller manufacturer, maybe a new startup, that could be enough to shove you out of that industry. So I'm just trying to understand better the qualification process or the cost-benefit analysis. Who does that? And where is that transparency? How do we see it? Because if an AHJ or 3 or 4 AHJs or 3 or 4 insurance companies can push UL to develop more standards that increase the cost of our products, I think EGSA has a responsibility to get much more involved in that process, because at the end of the day, we represent customers.
That's right, and that's exactly what I'm saying here. You got it. You hit the essence of the whole entire presentation. Is if you guys get engaged, you won't see issues like that. So you're exactly right. Yep. Thank you. Okay, good. Thank you, sir. Thank you.
Excellent job. And I'd like to thank Steve Stoniak for your 14 questions. You know, what I get out of this is UL is our partner, not some third-party feared entity that we maybe have defined in that fashion in the past. But one quick story. We had a live heat test, water test at Gillette. We had a water test going on, UL water test. We had a witness test going on. We had UL people on property. We had a heat test going. We had a load bank wire that fried. We got hot copper balls flying all over the floor. We got chaos. We got technicians running for cover, and we failed the test. It was like 4 o'clock in the afternoon. We wanted to get it done. You know, otherwise, the technician was going back to Chicago. We would have had to reschedule. It would have been a couple months later by the time we get him back. And the guy stayed till we had a solution, got the solution in play, which to get it done, we had to stay and continue the test till 11 o'clock at night. And the guy willingly did that, and we got the job done. Now, that's a good partner. That's a good partner. Jason, fantastic presentation. I also wanted to let everybody know he came down to Elkhart and gave me this presentation in the Gillette conference room in August just to make sure everything was cool. And that, to me, indicates a high level of service and commitment to the industry. So thank you.